Saxon's Trig, lesson 123, is talking about the general conic equation. So they review for you everything that we have been stressing about these equations pretty much all year long. So they don't review this one, but the equation for a line, y equals mx plus b. Anytime you have an plane y with an x that's squared or reversed, you've got a parabola. Anytime you've got an x squared and a y squared with a positive sign and the numbers are the same, and you are equaling a radius squared, you've got a circle. Anytime you've got the x squared, the positive, the y squared, it's equaling 1, you're dealing with an ellipse. Anytime you're dealing with numbers, and anytime you're dealing with the same thing, except with a minus sign with one or the other, it's your hyperbola. You also don't have to have the same numbers with this one. Their coefficients can be different. So they're showing you not in their simplified format, but in here they're doing their longer equations, such as for the parabola, this one, they're giving you something like x squared plus 4x minus y plus 1 equals 0. Or the other format where they give you y equals the x part squared plus a 2 minus a 3. That formula also works. Then for the circle, which was here, they're giving you the long version, something like x squared plus y squared minus 8x minus 4y plus 11 equals 0. Also, it's x something squared plus y something squared, and let me fill in their number, minus 4 and minus 2, and it equaled 9, that format. And then for the ellipse, that would be 4x squared plus 3y squared plus 4x minus 2y equals 0. So they're wanting you to know what their basic formulas were and then their longer versions when you multiply them all out. So notice on this one that the coefficients were no longer the same. This one's a 4, this one's a 3. For the circles, they have to be the same. And then for the hyperbola, the longer equation could be 4x squared minus 3y squared plus 4x minus 3y plus 7 equals 0. So you're focusing on the first parts with the squareds and their coefficients to try to figure out which you're dealing with, ellipses or hyperbolas. And because this one has a minus, that's easier to see. This one has the positive, so it's easy to tell the difference. Now, they do one new thing here, which is the term degenerate conic section, and it is if one of these equations fails and it gives you something like x squared plus y squared equals 0 for a circle. The radius is nothing, so it's not really a circle, it's a dot, so they're calling that a degenerate conic section, one that doesn't work. Now, they then shift gears and they say graph xy equals -4. So you're basically just going to pick your xy values and solve. But notice that when you have them multiplying together, the x and y axis both, did that backwards when I said it, x-axis and y-axis are both asymptotes, which skew me around them. So if I plug in 1, I should solve for the y. Y equals -4 divided by x. So when I plug in a 1, I get -4. And if I plug in 2, I get -2. And I know that this is an asymptote. So this is curving me here, and this one is curving me here. Then just do a couple of them in the negatives to establish the pattern. So -1 is going to be +4. and negative 2 is going to be the positive 2, and so I know that is going to skew me as it gets to the axis, and that one's going to skew me as it gets to the axis. Then in example 2, they completely change gears and they say identify what the given equations are based on the review that you just did. So in A, they give me an x squared and a 2y and some other numbers. And they say, what kind of a circle is that? Well, I have a plane y and an x that's squared. That's a hyperbola. Just a second. No, I'm sorry, parabola. I knew that didn't sound right when I wrote it. Okay, then in B, they give me a 2x squared and a 2 plus 2y squared. So I'm only pulling out the squared numbers. So they both have a x squared and a y squared. They share a coefficient of 2, which makes them a circle. In C, 2x squared minus 3y squared. Coefficients are different, has a minus, that's the hyperbola. And then in D, they give me 9x squared and 4y squared. Numbers are different. It has a positive, so that's going to be an ellipse. So if you have paid attention to all of your formulas and you already basically have them memorized, then what you're doing here in this to identify the equations should be fairly simple. One other thing, let me read something. The following equations of a circle, parabola, ellipse, and hyperbola, not necessarily in that order. Tell which they are and why, which we basically did, and then write the equation of the ellipse in standard form. So this one they want changed to standard form and then describe it. So to do that, I need the rest of that equation. 9x squared plus 4y squared plus 36x minus 24y equals, nope, plus, well, I'm going to go ahead and move that 36 over, so making it minus 36. So the standard form for the ellipse should equal 1. But I want to do the completing the square first before I do that. So 9x squared plus 36x should be together. 4y squared and 24y should be together. Pull the 9 out, giving me x squared plus 4x. Pulling the 4 out gives y squared minus 8y. Then completing the square steps. So, oh, I should leave the 9 there and I should leave the 4 here. Okay. Half the x is 2. 2 squares to 4. 4 times 9, 36, adding to the other side. And, oh, forgot to write the plus 2. Half of this is negative 4, squares to 16. 16 times 4, 64. Yes, I'd add multiply with 4. So then add that to the other side. So when I put all of that together, those cancel off and it equals 64. Now I know, oh, just a second. No, 64. Hang on, I've done something funny because I should be getting it equal to 36. Yep, here in my division. So when I pulled 4 away from 24, should have written 6, not 8. Half of 6 is 3. 3 squared is 9. 9 times 4 is 36. So this should have been 36 being added in here. So they killed each other off, but left me 36. Now we're back on track. Dividing every piece by 36 now gives us reducing x plus 2 squared over, and 9 over 36 reduces to 4, plus y minus 3, oh goodness, 3 squared, and then 4 over 36 reduces to the 9, and the problem equals 1, so we've put it in standard form that it asked for, and describe it. Okay, so where is the center of this? It's at -2, +3, changing the sign as we pull away from the parentheses. And that's an ellipse, the squish circle. So the only other thing they could ask for is the major and the minor. Yes, okay, so major equals and minor equals. So the distance here is square root of 4 is 2, doubling back to 4. And that's going to be the smaller of the numbers, so it's my minor. Square root of 9 is 3, doubling to 6. 6 is longer than the 4, so it is the major length. There's major axis. Oh, okay. And which direction is the major? So the larger one was with the y, so that makes it the vertical axis. So the vertical is the major at 6, and then the minor length of 4, and the center, we've identified everything that they asked for.